All right, so let's put those steps to work by trying a couple of problems. I got example one. All three, A, B, and C, are up on the board so that if you think you can handle it, you can keep going, or you can just do one at a time with me. So as you can see, all three of these are quadratic trinomials. Highest degree is 2. Each one has 3 terms. Now, let's look. Here's your first quadratic. Is there a GCF? What is the GCF between 1, 9, and 20? Well, if you need to take a minute, you can, but you'll realize the GCF is 1 because 9 and 20 don't have any common factors. So for the most part, there is no GCF. GCF is 1, kind of doesn't count. So we've taken care of step number 1. So now let's go to step number 2, your magic X. So you literally need to draw an X, ladies and gentlemen. There's an invisible 1 right here. 1 times 20 is 20. See, that's the A times C. See how that works? That's the A times C. My B is the middle coefficient, -9. So in your mind, well, not in your mind, we'll break this down a little bit. I need to find all the factors of 20. So I'm going to go over here on the side. I don't know if you can see, but if I have the number 20, I know that I have 1 and 10. I have 2, not 1 and 10, 1 and 20. 2 and 10, 3 doesn't go, 4 doesn't go. No, 4 does go, 4 and 5, right? Y'all see that? Now, between these 3 pairs of numbers, there needs to be a way, whether I add them or subtract them, that I could get a -9. Now remember, negative numbers work too, so you can't just think positives, all right? So when I look at these, the first 2 don't work, but I know that I can do something with the 4 and the 5. Well, to get the -9, the 4 and the 5 would both need to be negative. Is that okay? -4 plus -5 gives me -9. And -4 times -5 gives me 20. So I have correctly completed my X. These are the numbers that I filled in for my box. Now, speaking of the boxes, we're ready to go on to the next step. Draw you a 2x2. And you got to remember where everything goes. The first top corner gets the first term. Bottom corner gets the last term. Your diagonal gets whatever numbers you chose times X. And it doesn't matter where they go. So that's -4 times X and -5 times X. And so now we get our GCF. Let's do this first column here. What is the GCF between 1 and -5? Well, it's just 1 because that's all that goes into both of them. And if you remember, when we talked about GCFs for your variables, I told you in section 10.5, always take the variable with the lowest degree. If I have an x squared and an x, the x is the lowest degree. So the GCF between these 2 terms is just 1x. Now let's do the same thing here. I have -4x and 20. Well, what's the GCF between 4 and 20? Now, if you need to write it down like we did in section 10.5, do that. But I know that 4 is the greatest common factor between 4 and 20. Now, notice, this is a -4. So the GCF takes on whatever sign comes from my magic X. So if my magic X gave me a -4, then my GCF has to have a negative as well. My variable doesn't get included because my 20 doesn't have an X. The X is not common, so it's just -4. And then we're going to do the same thing across. What is my GCF between x squared and x? Well, the GCF of the variables is just x. And then I look again, GCF between 5 and 20. Now, if I'm going fast, that's because you can stop and figure this out on your own. But between 5 and 20, the GCF is 5. That's the greatest number that goes in front and goes between both of them, is in common. If this number from my magic X is negative, then the GCF is negative. So now I found the GCFs for both columns and both rows. All I got to do now is put it together, and I've got my linear binomials. So my first linear binomial is 1x minus 4. My second, well, you don't have to put the 1. My second binomial is x minus 5. And ladies and gentlemen, I'm done. If you don't believe me, if you Xbox this, you'll end up with exactly what we started with. Okay? That's our first example. I'm going to stop the video.